Hello class, so we're going to be looking at the review questions on similar triangles. Alright, so let's get started here. So in the component diagram here we have two right angles, and this length is 16 while this one is 12, and AE was equal to 8. Now we are looking for EF. That is the question mark. If it's called this one equal to X, then what's going to be happening is this. We can set up the ratio 8 to 16, meaning the small side, the vertical side of the small triangle to the big side, the vertical side of the big triangle, which will be 16. That is equal to x over 12. And obviously, we can cross multiply them if we wanted to, or you can realize that this is simply doubling. So we just have to double here. That means x must be equal to 6. Alright, so that's our answer. Alright, let us look into the second question. In a right triangle ABC, altitude CD is drawn to hypotenuse. Hypotenuse is AB. So then in this case, what we get to realize is this. Once we have the right triangle, we can assume that the AB is the hypotenuse, then angle C must be the right angle. Now, the hypotenuse is drawn. Around here, let us say, so that AD is equal to 4 and DB is equal to 9. We want to find out the CD, which we can call it as X. Now here we realize that the small triangle on the left side is in fact similar to the small triangle on the right side. And if you have to set up the ratio, one thing that which we get to realize is the line segment CD, which is equal to X, X is corresponding to this line segment 9, and 4 is corresponding to X from the big triangle. Now, another way for you to do this one is something called smiley face. In this case, that's something that I just called it. For example, here we have that's one side, hypotenuse times the leg times leg. This side is equal to one part of the leg times the other part of the leg. In fact, if you have to rotate it, it looks like a smiley face. Now, then in that case, one thing that which we get to realize is x squared must be equal to 4 times 9. Then we get to realize x must be equal to 6. So therefore 6 becomes our answer. Alright, let us look into the next question here. Similarly, we get to realize that here I'm going to just turn it this way a little bit. And then hypotenuse CB, hypotenuse AB is drawn right over here, and then C is given. Right angle, right angle. Now, here CD is equal to 6, and AD is equal to 3. So in fact, it might be better for us to switch A and B. Then this will be equal to 3. Now, what we are looking for is DB. We can call this one as X. Now, just like earlier, what we get to realize is this. If you square, in fact, if you multiply 6 times 6, So we're looking at vertical times vertical, and then left side line segment times the right side line segment. Left side line segment times the right side line segment. In fact, their product has to be equal to each other. Now, when you look into that, then it looks like smiley face. That's why we are calling it the smiley face method. Uh, Regardless what the method might have been, the relationship is 6 squared, which would be equal to x times 3. Then we get to realize 36, which is equal to 3x, which gets us x to be equal to 12. So that's equal to 12. Alright, let us move on. Here we have AC is equal to 3, and then DB is equal to 4. So we realize corresponding sides are 3 to 4 ratio, where AB is equal to 14. So then here we can call this one as 3x by the ratio of 4x. Then we get to realize 3x plus 4x must be equal to 14. Then we get to realize that x must be equal to 2 by adding these two, which is equal to 7x being equal to 14. Now then x equals 2, then here we have this portion is equal to 6 and this portion is equal to 8. We are looking for AE, so AE must be equal to 6 right over here. Alright, number 5. We realize that this line segment is 6, while this line segment is 3, and then we are looking for EC. Now, yes, I understand that we can set up the relationship to 6 to 3, but just for the unity within the similar triangles, what we like to do is 6 to the 9, meaning the entire side of the longer side of the bigger triangle. I mean the long side of the bigger triangle, corresponding size. And the other side becomes 10, which is corresponding to 6. So a line segment that's corresponding to 9 will be 10 plus x. When you cross multiply, then we get to realize here 90 is equal to 60 plus 6x. Now we get to realize 6x must be equal to 30. Then x must be equal to 5. So therefore, x is equal to 5. Choice D. Alright, let us move on to number 6. Now here AB is equal to 5. And then AC is equal to 10. And BC is equal to 13. But these are the midpoints. So therefore, each one is the mid-segment. Mid-segment is in fact half of its opposite side. So in fact, we get to realize that DF must be half of 13, which is 6.5. DE must be half of 10, which is equal to 5. And EF must be half of 5, which is 2.5. So when you add up all those three values, 2.5 plus 6.5, we get to realize that that's equal to 14. So therefore 14 must be its perimeter. Alright, let us continue. Number 7. Ratio of the corresponding sides is 7 to 5. And find the ratio of their perimeters. In fact, perimeters will still be 75. Same ratio, because if I were to examine one triangle, such as a small one, and let us say I have another one that's a little bit bigger. So what if I call the ratio as this one is 7, while this one is 5? then this I can rewrite this one as 7a, while this one is 5a. Then this can be 7b and 7c, while this one is 5b and then 5c. We get to have two similar triangles in the ratio of 7 to 5 on corresponding sides. Then perimeter here becomes 7a plus 7b plus 7c, while this one is perimeter for the smaller one become 5a plus 5b plus 5c. You get to realize that this must be equal to 7 times a plus b plus c, while this one is equal to 5 times a plus b plus c. Therefore, even the perimeter is still 7, 5. Alright, number 8. Sides of the triangle is 3, 4, 5. Find the length of the shortest side of the similar triangle. We are looking for shortest side. That means we are looking for something is corresponding to 3, while the longest side has length of 20. So 5 is comparing to 20. That means while 5 is compared to 20, what's happening with the line segment that is shortest, which corresponds to 3. So when we cross multiply, then we get to realize 5x equals 60. Therefore, x must be equal to 12. And therefore, 12 becomes our answer. Alright, here. Which pairs of triangle must be similar? In order for them to be similar, first angles has to be the same. Two right triangles? Not really, because we don't know about the other two angles. Two isosceles triangle with the congruent vertex angle. In fact, the correct answer will be choice C, because if in isosceles triangle, if this angle is congruent to this angle, while this angle must be congruent to this, that means the other remaining angle must be also the same as these. You can use an example by substituting particular vertex angle, and you will realize that base angles must be always the same. Alright, number 10. Here we have DB is equal to 6. Now AE is equal to 8. Now EC is 3 times of AD. So if we call AD as x, then EC must be 3x. And we need to find out AD, which is x. So the ratio becomes x over x plus 6 by the two corresponding sides is equal to 8 over 3x plus 8. Now then when we cross multiply, then we get to realize 8x plus 48 is equal to 3x squared plus 8x. Now we can subtract 8x from each side, cancels out, and then we can divide by 3, then x squared must be equal to 16. Therefore x must be equal to 4. That makes this one equal to 4. Alright, let us move on. Number 11. The sides of the triangles are such 3, 4, 5. I find the length of the smallest side of the smallest triangle whose perimeter is 8. Now what is the perimeter here? This will be 3 plus 4 plus 5, which will be equal to 12. Perimeter is equal to 12, while the other perimeter is 3. So from the previous question, we get to realize the ratio of the perimeter is the same as ratio of each individual corresponding size. Now here we are looking at the finding the smallest side. That means we are looking at something that's corresponding to 3, which we do not know. But while the perimeter of that triangle is 12 and the perimeter of the smaller triangle will be equal to 8, then what we're going to do, we're going to cross multiply them, which we get 12x must be equal to 24. As we divide by 12, we get to realize that x must be equal to 2. Alright, let us continue. Number 12. In this case, we have the small triangle and big triangle. One thing that which we get to realize is angle B is congruent to, if I were to call up a dot, ADE. ADE. These two angles are congruent. Now, angle C is 80, but we get to realize that, hey, wait a minute, this angle is common. So, we get to realize here, x plus 80 plus dot. When you add up those three, it must be equal to 180. But we get to realize that, hey, x and dot we have. We don't have the third angle. And third angle must be same as 80. And that's how we can figure out. Alright. Number 13. And then similar triangle as before. And then we will have hypotenuse drawn. So AB and D is given in this way. So DB is equal to 16, and then AD is equal to 4. We'd like to find out CD. Once again, by this modification, we have to realize that altitude times altitude, which is x squared, must be equal to the product of the two, the other line segments, which is 16 times 4. So we get to realize that x squared is equal to 64, and which makes x equals 8. Alright, that's it. In triangle ABCD is the point on AB, and E is the point in AC, such that, so we are looking at a similar triangle. So DE, if I call this one as ABC, so D is on point AD, and let us assume that so DE is on point AB, and EE is on point AC. Alright, now AD is equal to 2, and DB is equal to x minus 1, and AE is equal to x, and EC is equal to x plus 2. Then how are we going to do it? The ratio is 2 over x minus 1 plus 2 becomes plus 1, which is equal to x times the whole thing, which is 2x plus 2. So when you cross multiply, then we get to realize 4x plus 4, which is equal to x squared plus x. Now bringing everything onto the other side, we get to realize that 0 is equal to x squared minus 3x minus 4. Since this is factorable, but x minus 4, x plus 1. Then we get to realize that x must be either 4 or negative 1, but negative 1 cannot be the dimension of the length of the size, so therefore only thing that will work is 4, which is AB. Alright. Similar triangle as before. So here we have So A, B, C, and we're gonna say my guess is if this is AE and then D is on point AB. Okay, so AB is equal to 12 and AC is equal to 15 and AD is equal to 8. Find the value or length of AE, which is equal to X. So all we have to do is X to 15 must be equal to 8 to 12. And we get to realize here we have 12x is equal to 120. Therefore, x must be equal to 10. There it goes, right over there. Now, with this one, we're going to finish up the part 1. Part 2 will be continued very soon. Alright, have a nice day. Bye.